Welcome and thanks for joining us. My guest today is Chris Usserman, the Global Public Sector CTO at Infoblox. Chris, thanks so much for joining me today.
My pleasure.
Yeah, of course. Always good to have you. Well, NIST recently released an update to Special Publication 881. That's the first major revamp in more than a decade, and Infoblox worked closely with NIST on this effort. So, could you talk about the work you've done and what changes organizations should expect and what those changes mean for those that adopt and must comply with it?
I appreciate jumping right into it. The coming out hard. Um, the biggest aspect of it was obviously NIST's recognition that that there are a number of their publications that constantly needed revamping, and they're doing great efforts to invest in making sure that their directives, their guidance and recommendations to all of their consumers globally is now starting to move at the speed of technology, or at least closer to it, right? 12 years since the last update is a long time, but DNS has been around for over 40. So we actually have one of the core superstars of for DNS, Cricket Lou, out in California, and he's one of our executive vice presidents, and he was very critical, along with some of our engineering staff, around helping NIST understand why and how this needed to be updated, and actually as it pertains to threat actor activity and all of that. So, and it wasn't a hard sell for NIST. They already had it on the books. So there were a couple of component aspects that were really important. For a long time, DNS, the domain name system, arguably one of the most important protocols in internet parlance, has often been looked at from an IT point of view, much like routers for the infrastructure folks. You set it and you forget it. It's the George Foreman grill. You put it in the closet, you lock it up, you never touch it again so that it doesn't go down. DNS has been kind of looked at that way, because if it goes down, you can't touch printers, servers, the internet. And we've seen that happen. And so there were a couple of recommendations that were framed and worked with, that NIST collaborated with us on and understood. The key component of that is actually employing or defining what is called secure DNS, which actually goes, and if you see my eyes averting to another screen, it's to make sure that I get this accurate for the listeners. But it actually is three components, and that is, employing protective DNS, securing the DNS protocol itself, and securing the DNS infrastructure. And so we'll start with the infrastructure piece of that. And for those that remember, last July, a little over a year ago, I remember I was in Germany visiting a military installation, and we started seeing these Twitter posts come out, and the internet started going down. And it was because of a bad patch that pushed out from a vendor solution, pushed out to all of this critical infrastructure around the globe, and it shut down airlines and telecom and banking, and it really kind of upset everybody. The core reason why that happened was because a lot of the legacy DNS systems were running on servers that had other core functions on them. So part of the recommendation here is to have dedicated DNS servers so that you can have some desegregation of those core functions, so that when one service or one component goes down, it is resilient to any impact. Having high availability DNS servers also allowing for interoperability. The second is the DNS, securing the DNS protocol, right? It's it's not just DNSSEC as we traditionally refer to it, but using TSIG, encrypted DNS, as part of the mandate from M2209 from the OMB, and better DNS hygiene around making sure that you don't have names or subdomains that are out there that are just kind of dangling out in the ether, because those have been exploited. And then finally, it's actually using effectively what's called protective DNS. CISA has one that they operate for the federal civilian agencies. The National Security Agency operates a service for the Defense Industrial Base. And the MSISAC operates one for the state, local, tribal, and territorial. And they're also utilized around the world. The UK's got one for their government agencies. Australia has one. There are other countries as well that are adopting it. Effectively, what it is it's a DNS firewall, and it allows for applying intelligence, threat intelligence, and getting better telemetry around adversarial activity and unwitting and witting insider threats as well. Of being able to do and have forensic and forensic understanding of for incident response purposes, and that's really the key component. And lastly, it kind of formalizes the definition of what is protective DNS. And I will wrap all of that up and say, with the government's initiatives around zero trust, got a favorite marketing term, it helps further instantiate that. And I think we'll go into that a little bit more in a little bit. I know it was a long answer, but it was a big nearly a year's worth of effort.
We'll talk about that a little bit later.
Yep.
But in the meantime, could you talk about some of the challenges that you anticipate organizations um, might face when adopting the new guidance, and how does Infoblox might help with that transition?
So I'll start with the latter part. For those organizations that are already leveraging Infoblox for some of the core network components, like DHCP and DNS and or IP address management for real-time network understanding, it's easy to add on the licensing. If we're already there doing the DNS, the other component is you just turn on the feature that does the inspection and allows for the aspect of saying, hey, this user or this user system or this connected device should not connect with somewhere on the internet. The challenges that organizations are going to face are numerous, especially in the federal space, right? We already are hearing that there's going to be a CR through mid-November. So there's no new budgets. And so a lot of times when mandates come without money, there's no real incentive or ability for organizations to make those changes. So that is a challenge. So, the general government budget cycle always lends challenges to implementing these types of things. And so they have to potentially reprioritize existing obligations to determine the criticality and better manage risk. The other side of it is that for a long time, as I talked about previously, DNS has been on the IT front. Protective DNS really is kind of like the firewalls of next generation firewalls, wherein network manages the devices and security teams manage the rules. This will be the same thing, and so it will be another touch point for both sides of the house to figure out how to work along and work better. And then obviously, how does it support some of the other initiatives in visibility and prioritization of tasks within an agency's budget cycle?
Very quick, do you have any advice for the agencies who do have multiple priorities, modernization priorities, who are, juggling all of those things at the same time? Do you have any advice how they can balance that?
One of the key things is I often analogize cybersecurity to physical security. If you've got a hole in your front gate, if you've got a window that's broken in, the front of your house, that becomes a priority to fix, right? The perimeter security is important. This is just as important as some of those components. And so it really is a risk management decision, but it needs to be informed. What are the types of threats that an organization is facing? How does this help address those threats? And how might it how might it solve, say some, great percentage of the problem. Just as an example of that, I was at a conference, government conference a couple of weeks ago, and the government technology lead for the security division said, we're working with Microsoft to update the DNS or update Microsoft email server services like Office 365 to have anti-phishing built in. Okay, phishing is just one component of this, right? If you abstract out the methodologies, the DNS component is critical to all kinds of infection vectors, like phishing, like other components, as well as the use of malware itself.
At the same time, agencies are grappling with a constantly evolving threat environment. Um, Advanced persistent threats are on the rise. At the same time, more advanced ransomware attacks are still a major concern. So, could you talk about Infoblox's perspective on these ever increasing threats?
Oh, everybody's fun target, ransomware. The newest is obviously front of mind is AI. I look at these things, I've doing a little bit in the healthcare sectors recently. It's been a drive from several different industries. I equate ransomware and say APT threats akin to other medical components, right? Ransomware is a lot like the flu. It hits you hard, it hits you fast, it knocks you down. And if the underlying individual or network is healthy, uh, you'll be back up and operating in a week to 2 weeks. Maybe not full speed. It might take a little while, but you'll be up and operating. APT threats are intended not to be discovered or intended not to be found, and that's a little bit like a cancer, right? You're moving along, and there's a little bit along the way, and then suddenly, you find out that things are really bad. And that's what it is. All of those components are, we look at the effect and we try to address the effect and not the prevention component of it. Some would argue in healthcare that's true. Exercise versus pharmaceuticals, but also the same holds true in cyber, right? Can we prevent these things from happening, or at least make it extremely difficult for these to happen? Um, the Mandiant in their M-Trends 2025, cited the global median dwell time for malware was 11 days between the time that it was infected and the time it was discovered. That's for one incident, one event. That's a long time. Uh, when you have ransomware pop in there, it actually drops down to 5 because they want to be discovered. They want you to know they're there. And that's really interesting in understanding how do you address both of those. Well, you go down to the services that they are required to operate and leverage and use. You look at the network component, you look at some of the other aspects and figure out where's something that I can do that can affect and impact all of these different types of effects, whether it's ransomware, APT, other things. And that's DNS.
Yeah, and going back to what you were talking about at the beginning, one way federal agencies are trying to stay ahead of those threats is through zero trust. Um, yeah, could you talk about how Infoblox actually helps federal agencies advance zero trust objectives? We've been talking about zero trust for so long. But yeah, could you focus on how you help advance those objectives, and particularly in alignment with CISA's guidance and the push for deep network visibility?
So when Infoblox introduced Universal DNS, DHCP, and IPAM service, which is a SaaS capability, it's actually hybrid that actually leverages some of our existing components that are on-prem. We now have, and our customers by proxy now have the visibility, real-time network understanding, utilization, addressing, etc., for bare metal, for virtual and cloud in one platform. Now, when you add the protective DNS onto that, it gives you the ability to apply those security policies based off of device type, geography, carte blanche, etc., whether it's on premise, off premise, all of that. So what does that solve? What's the value of that to a customer? Well, one, I now have real-time understanding of everything on my network that has an IP address. My security teams can now have attribution to understand the resource at risk, wherever that device is, whether it's a virtual machine, a cloud resource, it's a user on the fourth floor of some building in DC or Kansas City, or they're at home or a conference. But I also have the ability to apply the NIST 881 protective DNS controls and satisfy the mandate from CISA around implementing protective DNS. And I can do that at the layer of one hop off of an impacted or potentially infected device. So where zero trust comes into play, I have real-time visibility and I have the component of restricting outside access. Most of what I've heard and what we've seen in the marketplace around zero trust is the idea of protecting from the outside in. How do I, identity access management, all of these components. But what we've actually seen from real attacks is it's coming from users who are already authenticated. It's coming from their systems. It's coming from processes that are already happening and are already approved that are being usurped by threat actors without their knowledge. So the biggest soundbite I could say from that is, why are we trusting the internet? Why are we allowing our networked systems connectivity to go anywhere in the world that they want to, unless it's on a specific list that somebody has deemed to be not safe? Why are we otherwise trusting every destination? And we shouldn't.
And I was just wondering if there is a use case that you could share or that you could highlight where Infoblox helped an agency move closer to meeting zero trust targets.
Absolutely. So we are implemented and installed across every cabinet level department and large swaths of the Department of Defense and most of the intelligence community agencies in the IC backbone. Uh, so we've got a lot that, obviously we can't attribute it to a specific agency, but one of the components that was really integral for one of these organizations was they had over 80,000 users on their enterprise. And that, if you attribute roughly 5 IP addresses per, that is a huge amount of devices on a particular enterprise. And, it's over 1.2 million. And they didn't have the visibility they needed. They were geographically dispersed. They didn't have a real understanding, but they were using us for DNS. They were using us because it was more resilient. It allowed for a lot of flexibility. So they had the IPM piece, that IP address management, that gave them some understanding of everything on the network. What they didn't have was the component that allowed for them to inspect and evaluate where systems on their enterprise were going out to the internet. And so we were actually, so when we talked to them and showed them the risk and helped them better manage that risk through a security workshop, we were able to apply that and they were able to see actually which devices, and it was, for lack of a better term, an oh crap moment when they realized that there were particular systems that had identifiers tied to individuals that were, in the one particular case, the individual was on vacation, but their system was communicating with an outside destination. So they were able to correlate all of this activity as well as the context with why it was bad, where they were going, and they were able to shut that down before it became a bigger problem. And so that was, and it also empowered the rest of the investments that they had already made within their ecosystem, from firewalls to phone scanners, et cetera.
Another challenge that I wanted to make sure that we touch on before we run out of time is the software supply chain. Um, could you talk about the steps that organizations can take to be more resilient when it comes to, the rise in software supply chain attacks affecting vendor products?
Trust but verify. And I don't mean that specifically of the sourcing itself, right? Obviously, I mean, we've seen last week NPMs getting um, dirtied up, and from a software supply chain point of view, and that affected a couple of security OEMs as well as others. We've seen it time and time again. This is, a very capable method to get into the supply chain to get delivered as a trusted Trojan horse, if you will. Uh, the best component that you could do is evaluate your systems, right? Watch the watchers. This is a legacy as old as time. Trust but verify. How are you determining that your protection systems are operating in the way that they should be, and that they aren't communicating or acting in a behavioral way that is counter to the way they should be? And I would say that's the biggest component. How can you evaluate that? And as a self-serving plug, one of the most agnostic ways of doing that is DNS. Can you watch and see, why is my uh, patch management solution communicating with a domain or a top level domain or a part of the world that it should never be communicating with? And that's, you got to have that visibility.
Yeah, absolutely. And that's the theme. You got to have the visibility. And Chris, before we run out of time, I wanted to make sure I ask you about you and your priorities for fiscal 2026.
From an Infoblox point of view, because mine are obviously more vacation and more places to visit, but from an Infoblox point of view, it's really getting organizations to better understand that the realm of the possible is actually real today. Um, that leveraging AI doesn't have to be scary, that having 100% visibility of your enterprise is absolutely possible because our customers are doing it, and stop trusting the internet. That's it. If we can get organizations to understand that, and that you can in fact do that today, with a better prioritization of your resources, um, then it's a win.
Excellent, Chris. That was a great conversation. I wish we had more time because I had a lot more follow-up questions for what you
Thank
just
you.
said. Yeah, but I want to thank you. It's been a great conversation. It's always good to have you here.
Appreciate it. Thank you.
I'd like to thank today's guest, Chris Usserman, the Global Public Sector CTO at Infoblox. I'm Anastasia Obis, and you're watching Federal News Network. Now let me send you back to the studio for more on the Cyber Leaders Exchange.